Good morning everyone. In the previous video, we tried to calculate the correlation coefficient using the formula covariance, where covariance between x and y is equal to r correlation coefficient multiplied by standard deviation of x multiplied by standard deviation of y. And using that formula, we will able to get the correlation coefficient equal to 0.9083. Now we are going to use different formula to calculate correlation coefficient, and the formula is shown on the right hand side. This is pretty long formula, but we just need to know how we can use this formula to calculate correlation coefficient. Nowadays no one remembered the formula because you have all the functions available in the Excel, or you can just go to your any standard stat books and you can find the formula over there. So let's try to calculate correlation coefficient again using this formula, and then we will also try to calculate the regression coefficient, which is b and a, using these equations. So let me first delete few data point here, few information here. So I'm just going to use the formula. So this is the standard formula given in the Excel to calculate correlation coefficient. It should give us the same value, 0.9083. Then I will remove all of these extra information. I will remove this. I do not need degree of freedom here. So I have the average number and I have the sum. So now my x values are the money supply growth rate and my y values are the inflation rate. So what I will do is get my xy, so that xy is being fed into this formula. So I need to get my xy, so that will be x multiplied by y, and then I will drag it down. Then I need my x square, so this will be my x multiplied by x, so that's my x square. I need my y square, so that will be y multiplied by y. So I got my x square and my square. My x square value will go here, y square value will go here. I have to calculate sum of x values and sum of y values. So sum will be, so sum for x values, sum for x values is this, and sum for y values is this. I do not need to show it here, so I can remove it. Then I also need the sum for my xy values. So sum for my xy values is equal to this, and then I need sum for x square and sum for y square. So I have all the values here. N is my number of count, so number of count will be is equal to count. I'm just gonna count like how many x y data points I have. So I have total 6. So the formula is saying that you can calculate the correlation coefficient, which is equal to n, and the value of n is right here, which is 6, multiply by sigma xy. Sigma xy is this number, sigma xy 231, minus sigma x is this value, sigma y is this value, then divide by square root of n, 6, multiply by sigma x square, so which is right here, minus sigma x square, sigma x and the whole square, so which will be basically square of this number, multiply by square root of n, which is again 6, multiply by sigma of y square, so that number will be 79.59, minus sigma y square, so sigma y square, so square of this number. So if I input all of these numbers into my big equation here, I should be able to calculate my correlation coefficient, and from this formula my correlation coefficient should be exactly same as 0.9083. so let's calculate the numerator part here. Is equal to, I know n is already 6, so I'm just going to remove that. 6 multiplied by sigma xy, so sigma xy is right here, minus sigma x is right here, multiplied by sigma y, that number is here. So this is what I have in the numerator, and then in the denominator I'm gonna calculate square root square root, then I have 6 multiplied by sigma x square, so that is this number, minus sigma x and the square of this thing, so which will be this multiplied by this. So I will get this. This is so this 28.44 is basically this section, section in the square root. Similarly, I will calculate for my y, so that will be sqrt, then 6 multiplied by sigma y square, which is 79.59, minus sigma y, this multiplied by itself. So this is what I got. So now what it says is that to calculate r, you have some in the numerator, some in the denominator. So you are basically gonna take what is in the numerator, divide by this, divide by this. So once I hit the enter, I should be able to get 0.9083. So I'm getting 0.9. So if I just like extend the decimal points here, so I will be getting 0.9083. So you can see that we can use this formula to calculate correlation coefficient, and this correlation coefficient is exactly same as I got using Excel formula. So this is one of the way to calculate correlation coefficient. The other one is basically using covariance, where covariance is equal to r multiplied by standard deviation of x multiplied by standard deviation of y. So now what we know here is that we have to calculate the equation of the regression line, and the equation of the regression line looks something like this. So that equation of the regression line will look something like this, where y is equal to a plus b x. So in this, b is the slope, a is the coefficient intercept, y is your just y values, and x will be your independent variable. So this is how the regression line will look like. And in this regression line, to get the regression line, we have to calculate the slope coefficient as well as intercept coefficient. So slope coefficient b, we can calculate the value of b from this formula right here. So we already have all the input numbers to calculate this formula. So let's get the value of b. So b equal to, so I'm gonna have in numerator, I'm gonna have 6 multiplied by sigma of xy. So sigma of xy is right here. To select the formula first, sigma of xy is right here, then minus sigma x and sigma y. So sigma x is here, multiplied by sigma y. So this will be my numerator, and in the denominator I will have again similar formula, 6 multiplied by sigma of x square. So sigma of x square is right here, minus sigma x square. So this is, which is this, multiplied by this. So this will be my denominator, and this number will be my numerator. So if I just get my ratio, then that will be my b, which is the slope of the line. So this is my b value, which is 0.33268. Now I have to calculate in this equation. You can see that I got my b value, x value is my independent variable, y is my dependent variable. I am still missing a, and the way I can calculate is that if I know the value of y and the value of x, I already know the value of b. So using these three known quantities, I can calculate the value of a. But then what should be my value of y and value of x? So whenever we try to use the linear regression equation, one thing we have to keep in mind, that this equation always passes through the average x and average y value. So it means that if I have average point here 9.7, which is the average of my x values, and then I have the average for my y values 3.2, so this equation will always pass through this these average x and average y value. So what I have to do here is, to calculate a, I have to use my formula y, which is y average, which is y average is right here, minus b is here, multiply by x average, which is here. So then my intercept, my a, will be this. A is equal to minus 0.03479. So this is my intercept value. So if I have to write my equation here again, the way I can write the equation is basically my y is equal to a plus bx. So my a is minus 0.03479 plus my b is 0.33268 and then multiply by my x values. So this is going to be my linear regression equation. So now let's see if I can get the same equation which I got here using the data analysis function we have in the Excel. So let me go to data here and then go to data analysis. So I am in data and data analysis, and then you can see this this pop-up window here, and I already selected regression here. So I will click on OK, and then just gonna remove all this first, so I don't have any pre-populated values. Now it asked me to enter the Y range. So Y range is my column C, so it will be from C3 to C8, and then it asked me to enter the X range, and X range is B3 to B8, and then it says that output option. So I'm gonna have output on the same sheet, and I would like to have my output somewhere here. So let's hit OK. So here is the regression analysis done by Excel, and you can see that intercept value here is 0.03479. So that's exactly what I have my intercept, 0.03479. And you can also look at the slope, which is x variable 1. The slope is 0.33268, and let's see what my slope is, 0.33268. So I got the same numbers which Excel is giving me, and my equation of line is this equation. Y is equal to minus 0.03479 plus 0.33268 multiplied by x. I will try to develop the plot between y values and x values and show you exactly same equation coming out just by my plot here, my scatter plot here. So insert, and then I will go to my scatter plot here, x. So this one will have my x and y values. Select data, add. So my x values are right here and my y values are here. So I have all the data points. I do not need this. I also do not need to show this. So I have my data points here. So what I'm going to do is I'm going to right click on this and add trend line, and then I will display equation on the chart, and it will be a linear. So the trend regression type will be linear, and then I want to show the equation on the chart so we can see how the y and x values look like. So you can see here that my regression equation, if I can enlarge this to make it better. So my regression equation looks like y is equal to minus 0.0348, which is 0.0348 plus 0.3327 multiplied by x. So I'm getting exactly same equation as we are seeing in this plot developed by Excel. So far we learned about how to calculate R, which is correlation coefficient, A, which is intercept coefficient, and B, which is slope coefficient. In my next video I will show whether if we have any way to judge whether these values are like significant or not. So in the next video I will show you how to do the significance test on R, A and B. So in that case, when we are doing the significance test, we will have our null hypothesis, which will say that the values are equal to, by default, or the null hypothesis will be that the values are equal to 0, and alternate hypothesis will say that values are not equal to 0. So I will cover that in the next video. Thank you.